So let's get started. I have a question. Have you signed up for your AWS account yet? Good. Have you tried it? So progress, but not very much.
Step by step. I have a bunch of things and like sub projects I want to do, and I want to do this and this and this and this. And unfortunately, so priorities. How often is a PhD candidate? I don't know their own research. He just goes around, explores the academic world on the ground.
That depends upon how good the student is and where they're at.
I read an article about a girl who she and her father built an airplane from scratch when she was 16. She just got accepted to Harvard PhD in physics, and she has like she gets to do whatever she wants, has no course requirements, and the staff can't interfere with it.
UC,
And also she's very smart. And she published like 3 papers before she was 18.
UC Santa Barbara has a program called, I forget what it's called now, Scholars Program or a Creative Studies Program, where you basically make up your own curriculum. And, no, undergraduate. Yeah.
Can you double the classes for AWS? Because this class applies to computational science and science masters. Can you count it towards? So then you would already have how to then program computational as well, right? That's what
the problem is, right, you can only be enrolled in one program at a time. No. Once you applied a course to one degree, it cannot apply to another degree.
Shut down.
Shall we start? So last time I started talking about running Spark on AWS, which reminds me before I go any further, does everyone realize that tomorrow is a holiday? Campus is closed. Which means I will not be having office hours tomorrow. So we're looking at running on Spark on AWS, and one of the problems we have is when you run Spark as a standalone program, the default is to get, lots of output, right? And it becomes hard to find your own statements. And let's see. Can anyone see where my output is? There's an obvious output that's not going to come from Spark. It took you a while, right? So it's a problem. And it's very irritating if you get those, 5 screenfuls of output, then you have to scroll up and down to find yours. And so we need to know how to deal with that. And Spark uses log4j, which is a common log program in Java. They currently use version 1, not version 2. And when they do, there's a number of different log values. You can turn it off, fatal error, and you can specify what level you want the output to be based upon per class, per package, per level. And you can also tell the logs to go to different places. You can tell it to go to a screen and to a file. There's all kinds of things you could do. And so one thing we can do is, here I'm just taking the logger and setting all loggers that come from the package.org to be air. And since my package is not .org, it won't affect it. And so I can now start getting my log manager, and I can do logs, I can do print statements, and then the output becomes just, you get several warnings in log4j because that occurs before you set the logger. And then I'm just seeing a lot less output. The problem is when you start setting things in your program like that, hard coding it, it becomes hard to change. You have to recompile, and so you can set it in a configuration file, and on the command line you can specify which file to use. The default is spark home config logj.properties, and there's a template you can edit and specify various things. So here's a slightly modified version of what they give. And you can set that various places. You can specify which one to use, but if you put it in the default location, it automatically finds it. Right, so specifying various things, where it should go, the console, create an appender so you can create files, and it'll then start putting them in the files. And so far so good. Now, one interesting thing about this room is usually when you've got a regular classroom, right, there's all the computers, and you're like, you can sort of pretend that maybe students are doing something related to the class. But when the students are on tables like this and they can see the screen, it's like, a few decades ago, it was common you could buy these special little screens over your screen so people couldn't see, right, sort of hide so no one else can see what you're doing. But again, when we're doing logging, remember the problem with Spark is that some of the code is being done on the master and some are being done on the slaves. And you have to be aware of when they're being done on the slaves, right? And so here, I'm doing several things. I'm running a log statement. That's on the master, right? But when I put it in a map, that log statement is being done on the slave. And that causes a problem. And the problem is, right, when I say get me the log manager and say equals log, that's being done on the master. It's not being done on the slave. And then what you do is when it comes time to start your slaves up, you then copy the environment from the master to the slaves, right, and send the jar file. And to do that, all the data you send to the slaves has to be serializable because you have to serialize it to send it across the network. And the root logger is not serializable. And so when you do this, you just get, I mean, it's just an error, but you can't run it. So there's a trick you can use in Scala to get around this. So here, let's see, an object means it's basically a static, right? So what does lazy mean in this context? It's not created until it's used. And now what does transient mean? You, you ignore that, remember, when you're serializing it, right? And so what happens now when we try and serialize this, it's serializable because there's nothing to serialize, and we extend it serializable. But when we actually run it, right, well then, you know, it will have that value, but we won't, the lazy says, oh, we haven't initialized it yet until we actually need it. So it's only, we only get that when we actually need it. And so now what we can do is we can then call it .log warn, and then it's going to be initialized when we need it, and that'll be initialized on the slave.
So then would any log files?
The log4j should send them to the same spot. Now, when we're dealing with AWS, we get a different problem, and that is none of your log statements are saved, whether on the master or the slave.
You said it's in the same place. What's the mechanism? Logs come from slaves in the master.
Yeah. Log4j knows how to send it to the right place, apparently. When you run it on your own machine, it's not a problem because it's there's only one computer. Yeah, I don't know what log4j would use, but probably.
Something related. You have it.
Right. No, we're just using standard log4j, right? Spark and Scala doesn't add anything to it. So you're probably right that you have to, right. when you run it on one single machine, it does work, right? And again, I didn't bother trying on Spark on AWS because none of the log statements come out on AWS. So, and if you want to log data frames, then you're going to have to put a log statement inside of a user-defined function, and then call that user-defined function in the right, because data frames, their maps are different than the maps on RDD, because the maps on data frames are on columns, not on individual elements of a row. So on Amazon, right, Amazon has what they call EMR, Elastic MapReduce. It does Hadoop and Spark and a bunch of other related things. You can create your own cluster. And when you go to Amazon, you can create your own create account. And in theory, you get 12 months free for many of their services. But it doesn't appear that running Spark is one of those services because neither I nor any of the students got that free service last year. So you do probably want to make sure you sign up for the $100 credit. You know, claim that S3 is free. We're not using EC2. We're using EC2, but through EMR. That's probably why we didn't get the free version. So go to educate site and sign up. And the pricing, they have a whole list of different levels of machines. Some are optimized for CPU, some are optimized for memory. And then there's usually a generation or two older ones you can also get. I wasn't able to get a lot of price information. But a current generation large costs 10 cents an hour. Doing spot is a lot cheaper, and according to documentation, they didn't charge anything for M1 large, which is probably incorrect. But we're not talking about a huge cost. Although you have to be careful because when you on the large version, it usually counts for each machine counts for 2 or 3 or 4, and then when you got 3 of them, and they count double or triple. But they claim to be charging per second now, so it's not like, well, a year ago they're charging per hour, so if you use 10 minutes and shut it off, you still got charged for an hour. And so then you'd, okay, I'll run it until 55 minutes and then I'll stop it, but then you missed it and you went over the 60 minutes. It wasn't that expensive. So basically, you want to run things locally first and debug it and make sure it works before you upload it. Do all your development and testing locally, and then you run it. You end up They use their S3 file system, which is a simple storage system. That's why it's S3. All the they have what they call buckets, and you put files in a bucket. The bucket names are global, which means you have to be slightly creative in creating your own buckets, because someone else may already use that name and you can't use it, which does seem to be right. Yeah, it's like you're creating a global file system you want millions of people to use, and there's no namespace going on. I mean, really? And when you log on to their website, you go to the S3 site, they give you a way of accessing it, look at the files, actually uploading, downloading them. There are various third-party libraries which do that. I've got a FTP/CSH client that I use because it's just faster and it's more convenient and does more things. There's a REST API, so you can write your own interface. And it's pretty easy to do. So I know people have done that, write their own programs and then use S3 to back up your computer, and you just run your Java program and it uploads the files and you put it in long-term storage, and it costs almost nothing. So you can either just use their system, or if you got some other program you use that can talk to S3, you can use that to upload and download the files. So here's my buckets. Create, the button to create a bucket, and you give it the name, and then you give it the what region you're in. For some reason, I ended up in the U.S. West Oregon AWS region, and so I didn't bother to try and change it because it seems fine, right? There is charges for S3, but that should be, if you haven't created an account before, you should be able to get that free for the first year.
Shall I call for you?
But there's a lot of, the costs are pretty low, right? The standard storage is like 2 cents per gigabyte. It's per gig, yeah. For the first 50 terabytes. And if you go above that, it goes down. And if you can move it over to infrequent storage, it goes down to, yeah, I mean, so like I said, I know people who actually just wrote a little program to upload all their files to S3, and particularly if, I mean, it's, right, I mean, just, and I follow various iOS developers, and a lot of them complain about the iCloud solution you use, that you can have your application is file stored, right? And they say, well, it's not quite right, and all these problems. And like, oh, let's do it ourselves, right? And it's cheaper. And when you put things in, we call them files. They call them objects. And the objects contain the file data plus metadata. You can go up to 5 gigabytes per object, which should be good enough. The buckets are basically, I mean, you give it names. You only get 100 buckets, which should be good enough. Right. Again, it's a global namespace, so And there are some rules, right? And part of the rules for names are dictated because when you want to access the bucket and the files through a REST interface, the bucket name becomes part of the URL. So it has to satisfy it has to satisfy those naming constraints. And there's a key for each item. And then the URL becomes, basically the bucket name .s3.amazon, and then it's the key. And this was doing a WSDL, which I think they dropped some time ago. I think most people have decided that SOAP is a waste of time and just use REST. And then you access control of all the buckets, of all your things. Each bucket has a access control list, so you can specify users and who can access the bucket. And then the same thing for each object can have access control, so you can have things which your whole team can access a bucket, but each individual item is only accessed by particular people. And so you can use it to store more than just things for Spark, but you can use it for other things and control who can access it. This is fun. It's not going to really affect us, but it's something you should know about because it's sort of weird when you first come across it. When you update something in a bucket, the updates are atomic, but S3 is a distributed file system, and so your file may exist on multiple machines at the same time. And so even after you've written to a bucket and changed something, you could do a read and get the old value. For us, it's not a big deal because when you can upload your jar file and then you're going to run the Spark, and then when it writes the output, right, it locks those files, so they're read only, so you can't write over them. But since we're talking about distributed computing and this file system is weird, so we have to look at what was called the CAT theorem. Anyone come across the CAT theorem before? Oh. So the CAT theorem talks about consistency, it talks about availability, and it talks about partitions. Right? And so first we need to understand what we mean by consistency, availability, and partitions. So if I have a database or some sort of data structure that's distributed on multiple machines, I'm just using two, so I start off and both machines have a copy of the same data thing. What happens now when you do a write to one of them? Well, all of a sudden it's not consistent, right? Because now one's got the old value, one's got the new value. So by consistency, we mean that, we always want all machines that have a copy of the value to always have the same value, right? When they update it, we then want, if you want the things to be consistent, we want the outside world to see that write is atomic. How do we do that? If I contact one machine and do a write to update the value to make sure that it seems atomic to the outside world, what you have to do is, before you do the write, that machine has to contact all the other machines that have got that value and ask them to lock the value. Don't allow anyone to read or write to it, right? And once they report back they've got the lock, then the first machine can now modify the value and broadcast the value to all other machines. And when all machines have got the new value, then we can unlock it, right? And that takes time, right? Because you have to get the lock, and then you have to, once you got the lock globally in all the machines, you can then have to broadcast the value. And if you're trying to create a system that has a high throughput, that's going to be a problem, right? Because every time you do this, now in a database, what happens is it's on a single machine. You don't lock the entire database, right? You try and lock just the one row so that other rows can still, other transactions can go on other rows, right? If you're on multiple machines, that's just much, much slower because you have to get the lock, and I got the lock now, and then so that's where you make consistency. Partition, what happens if for some reason the two machines can't communicate anymore, right? The network goes down between the two machines somehow. Now they can't talk to each other, and they don't know what each other is doing. And so if I modify one right, what happens? Now the problem is, how do you detect that there's a partition, right? Well, you send a message, it doesn't come back. How long do you wait for the message to come back? Right, I mean, it could be the network's very slow, right? It could be that the network's very slow and that machine's very busy, and so you're just getting, the network saturated, and so your packets are being dropped to some router someplace, right? So how do you know, right? And so really partitioning really amounts to how long are we willing to wait before we say, it's just screw it. I mean, it's too long, I'm just going to go ahead and do it. And so that leads us to latency, right? It's just the time between you make a request and get a response, right? And if you're dealing with a remote machine, there's always latency, but you have to control the network, right, and come back. And so partitioning, detecting a partition is just, you do it by latency, right? When latency gets too high, we decide it's a partition, right? And then we'll do something about it. But does it really mean that there's no way to get a message from machine A to machine B? Not necessarily. It just could be taking a long time, right? So in practice, when we talk about partitioning, we're really talking about is high latency. That's it, right? Being available, well, you have to be able to access that machine, right? So what does it mean to be available? There's no connection, a slow connection. What's the difference, right? Now, if your machine actually doesn't have network connection, you usually can detect that, right? I mean, the OS can say, I'm sorry, but there's no, I mean, I no longer have an IP address, right? But usually when you have this happens, it's not because someone's unplugged, right? Your network connection or your Wi-Fi base station went down, it's somewhere down the line. And so again, it really boils down to latency, right? Is this taking too long? Load the web page. I wait. Screw it. Just, I can't get there. Go some other place. Right. So when we talk about high availability, we really mean low latency, right? And so availability and latency are basically related too, right? Now, so what that means is the CAP theorem says that, so what does it say, right? If we go back to CAP theorem, it says there's three things, right? There's consistency, availability, and partition. We can't have all three. So we get to choose two. And so we have to decide which one we want. Which two we want, which one we're willing to if we want consistency and we want tolerance to partitions, then availability is going to suffer. Why? Well, because if you want consistency, every time you do an update, you have to lock down all those values, right? And that's going to take time. And that's going to really kill your availability, because whenever someone modifies that value, we have all this traffic going on to deal with it, right? So if we want to favor consistency over latency, what do we have to do? Well, if I write on machine A, I first have to get a lock, right, to make sure that no one else is reading the value after I write and before I update every machine. And then I can set the value in other machines to the correct value. And then I can unlock it, and all writes and read requests have to be locked. Postponed until that lock is satisfied, released, right? And that's going to greatly increase the latency, because you make a request and you're requesting something that's on a current lock. You have to wait till the lock is released so you can actually access the value. Right. If we favor latency over consistency, what we can do is just do the write, right? And don't worry about locks. But once we do this, at this stage, right, if a client comes in and requests a value and they're assigned, given access to machine 2 instead of machine 3, look at the old value, even though another machine, right, has the current value. But it greatly, it keeps the latency down, because we don't have that lock that locks on all the machines, right? And then we set it, and now we're back to consistency. This is what Amazon chose, right? Eventual consistency, right, yes. They'll sync it up eventually, but yeah. When I think about it, if you've got 100,000 machines, right, and for redundancy, you're copying these things. And each bucket is copied to multiple machines, just redundancy and increased throughput, right? To favor consistency over latency is can really slow the things down, right? If you got the same bucket on 5 machines, you have to figure out where the machines are and lock those things down. And so they chose latency over consistency. Like I said, in our use cases, it's not going to be a problem because you're going to upload the jar file and then you're going to run the program and it's going to write your output and it's write only. But if you're using S3 for a messaging system or other things, it's something you have to be aware of because the data is not always going to be consistent, particularly if there's a continuous stream of updates going on. It could take a while for it to propagate everywhere. And their documentation as well, just deal with it. So we can accept reads and writes while we're trying to update things. Is this clear? I mean, and of course you got this problem, right? What happens, right? You got 2 clients come in doing writes, and they get attached to different machines and they change the same value. Now what do you do, right? And so what you need some sort of policy to figure out how do you resolve this. And yeah, and it's even more interesting because some messaging systems have a retry if something fails. So it could be that your system retries it several times, do a transaction, and so you may end up doing the same write several times. And be careful to make sure that, particularly if you're increasing something by value and you do that several times, it's one of the fun things to deal in S3 on a general basis. Partition, what are you doing against partitioned, right? Well, the problem becomes if the network is partitioned in 2 pieces, what happens when 2 different clients talk to the 2 partitionings, and then eventually the network comes back together? How do you deal with that? I don't exactly remember, but I think S3 might be the last write wins. I forget. But So there's this cap theorem has been around for a while, and it's not really a theorem in a mathematical sense. People have pretty demonstrated it in theory. Physical networking works, but networking is slightly more complicated than this, and so people think it's slightly misleading. And the goal was really to focus people's attention on the trade-offs you're going to make, right? Do you really want to focus on consistency, or do you want to focus on latency, right? Which one is your priority? And yeah, S3 favors latency over consistency, right? So how do you run programs in AWS? Like I say, you make sure that the program runs locally. You create a jar file of the program. You have to make sure that jar file is a manifest. It tells where the main, and you then need a bucket or several buckets to contain your jar file, any input files you want and output files. And you load your data up to S3, the jar files up to S3, and then you can run it, right? Again, it's sort of a bad idea to hard code your input files in your program. So typically you're going to pass in as a command line argument which file is going to be input file. My simple example here is sort of like a hello world program. It's how small can we make it and still do all the things we need to do. So usually you'll have a number of arguments for input files and then some arguments for output files. Here I'm just doing one. And I then just created an RDD and wrote it out, right? SVT can create the package for us. That creates a jar file. We can run that locally inside of Spark, or we can upload it to AWS and run it. SVT has a shell, and if you're in IntelliJ, there's a tab on the bottom when SVT is installed. You just click on it, and it starts up SVT, and then you type commands. It's a little faster because you don't have to start up the process. And then you can load the commands. And if you're like me, you compile your program, run it, make a change, and do it again. So it's easier because then you can just repeat package every time you. And you get a bunch of stuff, and in your target / Scala directory, you get your jar file. And if you want, the jar file is just a zip file that contains a manifest. And the jar command will unpack it for you. And you can see what it contents. And it has this manifest.mf. And the important thing is it has a main class. Now, I'll warn you, if you're using third-party libraries, which you don't, well, if you're using third-party libraries, you have to make sure that they are included in the manifest file, right? Because, right, all the Spark libraries are provided for you inside the Spark environment, but any other library you use will not be. well, there's some exceptions that when you go on AWS, right, there's pig and various other things that you can use. They're provided, but otherwise, you have to make sure that they go into your jar file. Right, and you just create your buckets, upload your data, upload your jar file, and so here I have I have one bucket for my jar files I created a year ago when I'm doing Hadoop, so I didn't bother changing it. And I just created it. And then you create a cluster, right? So when you go to EMR, you can create a cluster, or you can see your recent clusters and you can clone them and run them again. When I create the cluster, there's a quick options, or you can do advanced options. The quick options specify where you want the log file, Amazon, which release you want, usually the current one, and then you want Spark. The advanced options, you get to pick, various tools they have, and then you want Spark application, and then you configure a step. I should point out, in both cases, you get to select which hardware you want. That is, which class of machine and how many machines you want. When you create a step, which we also call a job, you can either do the most obvious thing you do is do a Spark application, give it some name, that name that shows up as a step so you can know which one it is. You then, it's minus class, and the name of the main class that has your main in it, in your jar file. If you do not include that in your Spark Submit options, your job will fail. And then you need to give it reference to the jar file you want to run, and then any arguments you want to be passed to your program. And then you can basically, what do you want to do on a failure? You can have it continue. You can have it check on the quit if you want. You can also you get various options on what type of step you want to do. If you say custom jar, you can basically tell it the jar location is a command runner jar, and then you can just do the whole Spark submit like you would do locally. And then, of course, what you could do is you can copy that. So someplace where you can just copy and paste it, right? And then modify the piece you want rather than having it as it's S3 : then what's the name of my bucket again? And so when I ran it with three machines, I got 16 parts. So there's actually 16 different partitions. What's that? This one? Oh, the arguments, it's the deploy cluster, the deploy mode. There's basically two options for that. When it's cluster, your one machine is just used to manage the cluster, your cluster, and your client that's actually running your master program actually does not run on the master program, master machine. And I forget what the other value is. And when you actually when we do the quick options, that's one of the options that I think I didn't show that you can then select here. But the default is cluster. Any other questions? And so you get a lot of parts. And you should know how to reduce the number of parts. Yes, in AWS, it can take 5 to 15 minutes to start your cluster up. So you need to be used to that. That's a good question, and it's sort of bizarre because I did at one point terminate a cluster before it actually was running, and it showed 0 minutes, even though I had waited like 5 minutes. But when I don't terminate, it does seem to start from when I spun it up, not when it became active. Now, for those of you who like to do these sort of things, you can actually SSH into your cluster. And to do so, you need to create basically a certificate with private and public keys. You do that in the EC2 dashboard, and that allows you to do a number of different things. One, it allows you to SSH into your cluster. It also, you can use that SSH connection to tunnel, so you can actually look at the slave and master web pages that they run, like you can do locally. And it allows you to submit jobs and create clusters from the command line. So you don't have to go through the website. You can just do it once you got there, right? Some people want the web pages and some people don't, right? When you go through the web page, right, this is the quick options, and here's the pieces that you didn't see before. You can, what type of instance, you click on this and it shows you all the class machines are available, how many machines you want. And then there's EC2 pair keys. Once you create your key pair, you have to give it a name. And then when you click on this option, it'll show you all your key pairs. You can select which one you want to use. I only have one. And once you do that, then when your cluster is running, there's going to be a master public DNS, right? It gives you there's your machine, and you can click on that SSH, and it then gives you, here is your SSH command you use to log on to your machine. Although, once you've got that address, I mean, the command is pretty obvious. You need to connect to that machine, and you need to give it your public key. So there's a couple of command line tools you can use to interact with it. AWS command line tool. You can download it. It's a command line tool. The documentation is out of date, but the one good thing, I don't know if I remember showed it to you. There's actually some place on this web page. There's a way of saying, it's right there, right? You click on that, and it gives you the full command line that you can use on their tool to start that cluster up. So you don't have to, you can just basically start it up once through here, copy it, and then once you got that, it's like, okay, I know I can change this, this, and this to do what I want, right? So you don't have to read the manual and figure out which commands work and don't work anymore because they'll generate it for you. I think that the Flint Rock is has more functionality, but I haven't played with it. So if you like web interfaces, they give it to you. If you just want a command line interface, you got it. Any questions? I plan to get your assignment out tomorrow so you can have some motivation to actually do this on AWS. Questions? I'll probably give you 2 weekends. What? If I give you only 1 weekend, then it can't be as hard as it can be with 2 weekends, right? If no one has any questions, I think we're done for the day.